Hey everyone, today we're going to talk a little about symmetry with graphs. And I'll give you a couple examples here of beautiful pictures of symmetry. Some of you have heard symmetry before, but do you know what it really means? Well, if you have a picture like this that has symmetry, it just means there's some imaginary line that you can draw through it where one side will be pretty much an exact copy of the right side. So that I can almost fold one side over the other and each side would match each other perfectly. This one has a really nice symmetry, just straight up and down, a sort of a vertical symmetry, so I could fold it over like that. But if you also notice, because of the reflection of the water, this is almost a perfect symmetry as well. So this has two different types. So I just want to show you a couple really beautiful pictures, especially in nature. Nature is so pretty when it comes to symmetry, whether it's animals or plants. So many pretty examples. A lot of times symmetry deals with a line. You can be symmetric over a certain line. Sometimes it's not necessarily a line. It could be symmetric around a certain point. For example, this plant here is actually symmetric around a point. And it demonstrates a really neat example of what's called the Fibonacci spiral, if you've ever heard of that. Again, snowflakes. All beautiful examples of nature of symmetry. Beautiful examples. We never knew they were there, but now you notice them. Now, a little strange, but here's your teacher. And what I did in this picture, you can tell the sign behind me is a little strange, right? Because it's sort of reflected. This is a picture of me, but it's really actually a false one. Because what I did is I used a camera and I made symmetry. I took one side of my face and I just copied it on the other side and I tried to paste it together. So although it kind of does look like me, it's a little bit off. I'm not that perfectly formed on my face. Even with a smile. It's a nice smile. But you can see that because of the sign behind me, it is a reflection, so I am right now symmetric about the middle of my face. But it's interesting, it's pretty close to how I look, but not quite. So it's neat to see that we as human beings don't always have perfect symmetry. We are who we are. So here, let's go play. Here's how this is going to work. All right, this is section 1.2, and now that we're done talking about functions for a little while, we're going to talk about the actual graphs of functions. And in class, I think we played this great little quizzes where you sort of tried to recall the most common functions. Sometimes we call them the parent functions or 12 basic functions. And so you looked at some of these words here. We looked at graphs, we looked at equations, and saw what you knew. And that was a good just sort of review of all the graphs you've learned so far in your math career. So it's good to keep those in the back of your brain. Okay, moving on. Let's talk about symmetry. And there's two types of symmetry that we'll talk about today. One's called even, and one is called odd. Okay, the first one we're going to talk about is called symmetry in the y-axis. So our y vertical axis is sort of our dividing line that will cut our picture in half and show the symmetry. Now what happens? Well, let me show you. If I give you folks a point somewhere over here in the first quadrant, and I call that some point x, comma, y. No numbers, but just the letters. If I have symmetry in the y-axis, meaning if this dividing line cuts it in half, and the right side and the left side are exact mirrors of each other, then can you see where the point xy is going to go? First of all, can you see that he's going to go over here somewhere, but can you see exactly where? He's going to be somewhere about over here, I believe. That's where that point would flip over because of symmetry. Now, this is not the point x comma y anymore, right? X comma y was over in the right side in the first quadrant. Do you know what this is going to be? Think about what did you change, the x coordinate or the y coordinate to move over to the left? And it looks like if we actually use the numbers, it looks like the y coordinate stayed the same, but the x changed to the opposite of what it was on the right side. So if you see over here, if xy is on the graph, then the point negative xy would also be on the graph if you have symmetry in the y-axis. So if the y-axis would divide your graph or your picture in half, then one point on this side should be reflected to the same point on this side. So for example, if you had a smiley face over here, that would reflect over here to the same smiley face. Okay, if you have symmetry in the y-axis, we're going to give that a special name. If you're symmetric in the y-axis, we call that even. So even and y-axis are linked together. Okay, so if you're symmetric in the y-axis, the vertical axis, you have what's called even symmetry, or you're called an even function. The other type that we can have is symmetry across the origin. Now remember, the origin is not a line, it's the point 0, 0. There's your origin. Now how can you have symmetry over a point? That's kind of strange. But it goes back to that green plant that we saw where it sort of spiraled around. Here's what can happen when you are symmetric with the origin. Let me give you a point here. How about some point x comma y? Now what happens with the origin is he sort of flips diagonally over that origin, and he's going to land somewhere over here with my new point. That's symmetry over the origin. It's like I flipped over the point and I got this new symmetric point. Now, if that was originally xy, what is this new point over there? Did I change x? Did I change y? And in fact, you can see I did. I changed both. I made the x negative to the second quadrant, and I made the y negative to put it into the third quadrant. And interesting that we changed both, right? Because actually, if you think about it, what we could have thought of this as is a y-axis reflection, and then after that, an x-axis reflection, as if I just flipped over the x-axis as well. So symmetry in the origin is almost like a double symmetry. It's almost like a symmetry over the x-axis and then the y-axis, or y-axis and then x-axis, either one. But just know that if I have symmetry in the origin, then xy would be flipped to negative x, negative y. All right, let's give it a name. If you have symmetry in the origin, friends, then you are called what's called an odd function. Symmetry in the origin is an odd function. That's easy to remember because they both start with O. So origin and odd. If it's symmetry in the y-axis, it's just called even. So origin and odd. Okay, now that's interesting because we talked about the y-axis, check. We talked about the origin, check. But you know what we didn't talk about? We didn't really talk about symmetry over the x-axis. Why is that? I wonder why we didn't do that. Well, let me think. Let me draw a point here, for example. And if I was symmetric over the x-axis, can you see that the point would flip over here? And looks like the x is going to be the same, but the y flipped to negative. Okay. Do you know why we don't talk about this symmetry? Why do we skip this one? We do y-axis, we do origin, but we don't do x-axis symmetry. If you remember from the last section, can I draw this really famous line for you? There it is. Because of the vertical line test, if you have a function or a graph that is symmetric over the x-axis, he is not a function. Remember, this whole chapter is about functions, right? So we'll never talk about x-axis symmetry in this chapter. Because if you have x-axis symmetry, that means you're not a function and you fail the vertical line test. So we only have origin symmetry and we only have y-axis symmetry. Okay, so we can tell maybe by looking at it if it has symmetry, but how can we do algebraically? What if I throw a function or an equation at you, not a graph, and you have to be able to look at that equation or function and be like, ooh, what symmetry does that have? Without graphing it. Can you do it? All right, I'm a big fan of steps, as you learned from me this year. I love writing down steps because it keeps me sort of organized well, and it's really good for my notes as well. So feel free to write down these steps, or if you're printing out these notes, just sort of highlight important parts. Here's how you're going to tell, friends, if you have symmetry over the x-axis, the y-axis, the origin, or neither. Now, as we do this, I'm going to concurrently work on the problems on the bottom as well, so we can see them in action. Okay, so let's take number 1. Let's see if number 1, which is f of x, is x squared plus 2. Is that one even, odd, or neither symmetry? Okay, well, let's take step 1 up here on top. The first thing to do algebraically, friends, is why don't you replace x, that's in your equation, with negative x. Okay, let's see what happens. So number 1, let me put it down here. So let me say f of, not x, but how about negative x? We're going to substitute negative x into the game. Now, when you plug in negative x, friends, can you make sure that you really, really always use, I'll put a star over here, parentheses, just because it's a negative, and negatives are a little dangerous in algebra sometimes. So I'm going to put negative x in parentheses and the squared on the outside, so that I know that I'm actually squaring the negative as well as the x. All right, there's nothing on the 2 except the 2, so I just have it as that. Okay, cool. Step 1, done. Step 2, after you simplify, okay, let's simplify this and see what we get. So if I simplify, when I square a negative x, I get positive x. So it becomes a positive x squared plus 2. Great, let's go back to our step 2. After you simplify, here's your big question. Did you get the same equation back out? So take your answer that you had here and go back to the OG, the original. Is it the same? Yes, it is. And the good news is for part A here up here in step 2, if you got the same equation in, that means you found an even function. So he is symmetric over the y-axis. Yay, and you're done. Good, so this guy's even. You plugged in negative x, and what happens is you got the original function back out. So you got the original y value back out, which means he is symmetric over the y-axis. And if we actually graph this friend, number 1 is actually a parabola that's just been shifted up 2. So he's like this. And just looking at that visually, can you tell that that actually is a y-axis symmetry? So there you go. Let's try number 2. Okay, same step, number 1. Let's substitute negative x in for x. So g of negative x equals 2 times negative x minus 5. Okay, now it's not 2 minus x, it's 2 times the negative x, so I'm going to multiply, and that gives me 2 times negative x, just gives me a negative 2x. Minus 5 is still there. Okay, that was step 1. Let me do step 2, which means can you now, after you simplify, let's go back and check. Is this the same equation I started with in the original? Boy, it's close, but can you see the difference? Like the 2 is changed, but the 5 hasn't. So the 5 looks pretty good, still negative 5, but the 2 changed to a negative 2. So no, this is not the original. Okay, well, let's go back up here to the top. Let's look at step 2b. So no, it's not the same as the original. So let's check. Did I get the opposite of the original? Meaning, did all the signs change? If I had the opposite of g, let's see what that would look like. The opposite of g would look like a negative 2x. Instead of a minus 5, it should be a plus 5. That would be the opposite. Is that what I got? No, I didn't get the opposite either. So go to part C. So I didn't get the exact same as the original. I didn't get the opposite. So this guy's neither even or odd. So I'll put over here, this guy is a neither. He's neither even or odd. And I don't know if you recognize number 2, what the shape is, but he's just a line. He's a linear graph, slope of 2, and a y-intercept of negative 5. So he looks like this. And there's no real symmetry, y-axis, even x-axis, or origin that I can flip him over. All right, and the last one here, friends. Let's try number 3. Okay, first step, let's plug in negative x. Let's see what happens here. Again, parentheses are really important. 3 times negative x cubed plus, here's another x. Okay, for that x, I'm also going to plug in negative x. All the x's get to play. We're going to simplify. All right, negative x cubed. So, like, your brain is thinking negative x times negative x 3 times, right? Okay, these two would be 2 negatives. That would give me a positive x squared. And then when I compare that and multiply it with that friend, I should get a negative x cubed. So it becomes negative. Okay, and I have a 3 in the front, so it becomes just a negative 3x cubed. Don't forget the cubed, because he's being cubed. All right, and then I have a plus negative x, which is just the same thing as a negative x. All right, step 2. Let's double check. Compare this friend with our old friend. Is he exactly the same? No. So he is not even. Is he exactly the opposite? Well, look at this, folks. It's like I took the 3x cubed, and now he's negative. I took the positive x, and now he's negative. So is he the opposite? Yes. He is exactly the opposite. So look at 2b. If he is the opposite, therefore, you have odd. So again, another O word. That's kind of nice. Remember, origin symmetry is an odd function because you get the opposite function back out in the equation. So we got the opposite, which means this fellow is odd. He's an odd function, which is y-axis. I'm seeing it. He is odd, which is origin. Okay, good job. So there's kind of a nice example of each type. So let me give you one more to try just on your own, friends. How about I say f of x equals 2 x to the fourth minus x squared plus 1. All right, can you tell me if this is an odd, even, or neither function? Go ahead and take a break from the video, pause it if you wish, and come back and check your answer. Good luck. All right, friends, let's take a look. I think when I've done this one before, this one should be even. Let's see what happens. Ready? F of negative x, all right, negative goes for all x's, 2 negative x to the fourth minus, okay, watch this. I have a minus on the outside and a negative x on the inside, plus 1. Okay, I need a little bit of algebra magic here to simplify. Ready? Okay, this part here, when I do negative x to the fourth, that's 4 negative x's. That's 4 negatives. That changes it actually into a positive x to the fourth. And then when you multiply on the outside by 2, I should get a positive 2x to the fourth. Do you see that? The negative you multiply out 4 times, and so you should get a positive back out. Okay, over here, I should get a minus. Now be careful. By order of operations, we don't do this part first. We do this part first. So do your parentheses and exponent first before you multiply on the outside. Okay, so I should have negative x squared, which we did before. That's a positive x squared. And then you're going to multiply then on the outside by negative. So I'll get a minus positive x squared. And the plus 1, there's nothing to do, so it's just a plus 1. All right, algebra done. Let's compare. Look at our new function. Let's compare it with the original. Is it the same? Yes, it is exactly the same, which means he is, like we figured out, he's an even function. Symmetry over the y-axis. And there you go, folks. How did you do? Great job. There's a really neat intro to section 1.2, and we'll finish the rest of the section in another video. Good job, everyone.